All right, everybody. We'll go ahead and get started. I've just started recording this, so this will be available for others, either for you all to review or anybody you know who'd like to see the presentation and hear the Q&A. My name is Mark Easter. I'm a research associate here at Colorado State University at the Natural Resource Ecology Lab. I work in the research group led by Dr. Keith Postgen. And I'm going to be presenting on improvements to the COMET-Farm application program interface. I'm presenting on behalf of my colleagues who you can see here, and I want to send a special shout out to Mark Lane and Shobha Valayadhan, who have worked, done so much work on the API, and other people, unsung heroes within our group that have done a lot of work on testing and verification. So this is just, I want to call out thanks to the NRCS, National Resources Conservation Service, and the Climate Change Program Office at USDA for their long-term and continued support of the COMET tools. We've also received additional support from a number of different state agencies, in particular the California Department of Food and Ag, California Air Resources Board. Big chunk of the funding that supported the work we're presenting today came from the Farm Foundation for Agricultural Research and from private donors. And this is just a quick snapshot of our team members and colleagues at NRCS, the USDA Office of the Chief Economist, and the Agricultural Research Service. So here's just a brief roadmap of the presentation. We're going to be reviewing the COMET-Farm API and some of the capabilities it offers to users, but we're going to be focusing on new API features, and then talking about next steps for the API, and then going through some Q&A afterwards. We scheduled 60 minutes for the call today. I'm going to be available. I've blocked out an additional 30 minutes after the call is scheduled to end for anybody who wants to stay on and continue the dialogue. So this is going to be a real tech geek presentation. I'm going to, the assumption here is that the people who are joining the call know about COMET-Farm, they understand what it's about, how it's used, and we're going to be focusing on the technical details about how to interface to the tool through the API. Many of you are already working with the API, and others may it may be new to you, so happy to take any questions in that context. A new user and an existing user, whatever they are, I'd like to ask you to enter your messages into the chat. We'll monitor those questions as the meeting goes on and try to address them the best way that we can. If I could, can I ask everybody who's on the call to mute your microphones right now? So please go ahead and mute your mics and turn them on. If there's a specific question, if you want to call attention to a question that's topical or an observation, otherwise please record your questions in the chat. So the tool improvements that we're going to be describing today came from a long series of customer discovery interviews and feedback from users that we also received during the January 2020 presentation. A number of you were on that call. And I want to emphasize no current features that are available within the API have been deprecated at this time. So I'm just going to give you a quick review of the COMET-Farm API as it has worked up to this point, show you where the key change points are. And many of you are probably familiar with this diagram here. This is essentially an ecosystem map, if you will, that was drawn with OpenTeam. This was from a workshop that was done last October here in Denver. And what I think is so interesting about this is it illustrates a number of the different organizations within the OpenTeam environment that are interested in connecting to the COMET-Farm API, either to send model run requests or to have the opportunity to upload project details to initiate a new project from another tool or other sorts of interactions. This is just just one context that for the different sorts of needs that we're trying to serve. And a number of the members from Open Team are on this call, and there's a lot of people who are not on Open Team currently who are also part of this call, and you all are welcome. But this is just the opportunities out there for sharing information, either through model run requests or other aspects for the tools that we provide, are so so vast right now compared to what was possible even just a decade ago. It's extraordinary, and we're happy to, and excited to try and fulfill those needs. I want to call your attention to a GitLab repository where we've uploaded a number of documents related to the COMET-Farm API, and we've been actively maintaining these. And so within that, we have details about input and output requirements, how to connect to the API. We've got some sample scripts, an example XML input and output files that anybody can download and use. We also have some white papers uploaded that explain how to interpret the results coming from the tool. And so I want to encourage you all, anybody who has not been to that GitLab repository, to go there and have a look. And please don't hesitate to reach out to us with questions about what you find there and suggestions for improvements. There's two key ways that users can access COMET-Farm API. I'm going to take a quick drink of water, excuse me. The first way is a method that's been available for several months now. It's through a graphical user interface that we have, and you can see the link to that here. And this gives you the opportunity to bring up a simple page where you can control the API, identify what your email address is, and then send a file in, and then results get returned to that email address. The other thing that you can now do is you can specify a URL where you essentially have a server listening and waiting for a response from the API where it can accept XML files. And this is new, and that's why it's highlighted in red. We've just through the suggestions from this team and support from members of Open Team and other users of the API, we've set it up so that users can specify a URL so that can accept a response from a post request. Users can also access, you can view the status of your requests and other people who may be doing model runs through the API through this URL here, so that you can see maybe you uploaded a set of files and they haven't come back to you yet. You're wondering what's going on. You can see what the status of the API is on this page here as well. The API structure has simplified somewhat. We previously had a single COMET-Farm server that would accept web requests, model run requests, and we would send it to the Google Cloud, or we would send it to what we called our ROX cluster. This was internal. We've shut down that ROX cluster for outside use, and we're directing all of our model run requests to a set of API services in the Google Cloud. We feel like we can serve the user base better by doing that. We also found that with the global pandemic and users, there are so many users hitting the C-issue subnet internally for well, moving to an online education model, that we essentially didn't have the bandwidth to use the C-issue ROX cluster in that context anymore. So we've taken that down and we've beefed up the resources that we have in the Google Cloud. We've also worked to improve the controlling software to make sure that the queuing system works most effectively, and tuned it for maximum throughput. The other thing that we've done is previously users could only receive the results through an email response from the GUI. Users can send a post GUI request, but you can also embed within that post GUI request a URL. And you can either do that through the API or through the graphical user interface, or just directly in the post request that you send in. And I want to talk a little bit about what some of the different ways to connect to it are. You can either do a direct URL access where you set up your own listening server and you provide the URL to the GUI or to the API, either from the GUI or in your post request. The other thing that you could do is you could use webhooks, and this was actually the original request that came to us. And so webhooks is a pretty good opportunity in order to be able to make connections if you don't currently have the opportunity to set up a listening service. Now I'm going to be distributing this, making this presentation available within the GitHub repository, so you can all come to this. But if you do have specific questions about webhooks, I suggest you go to the site webhook.site and just have a look at what the details that they offer there. So some of the details that we offer within the GitLab repository are specifics on the input-output files. And we have an Excel file that we've uploaded there that we're currently maintaining. The most current version is from June 2nd. And in that file, we explain all the details around what the input file of an XML input would look like, and likewise, or what the results files look like. We have specific details on units, and we have other lookup tables where the list related of possible inputs for a number of different tags might be long, essentially too long to easily show within context of an Excel worksheet. And so we moved that into a separate worksheet to devote the adequate space for that. So I'd encourage you all to have a look at that. We are considering moving that into a Google Sheets format to make it a little bit easier to track changes over time and track improvements. A number of people have asked, well, why XML? And I wanted to take just a few minutes to explain that. When we first started working on the API, this was probably 4 years ago, XML was hot. JSON was around, but at the time we did some user interviews and nobody had actually requested JSON or another format to be able to send in a model request. So we went with XML, and now what we're hearing from a number of different people is that JSON would actually be a better way to go about this. And having looked into this and had discussions with a number of you, we agree, and this is something we've put on the plate to move to, so that we can allow input from either XML or JSON. Currently, it's still XML and it's going to remain XML, but we will be adding JSON as we work through improvements there in our queue. Okay, so now I want to talk about some of the new API features, specifically related to error trapping. So we've added a number of different classes of error trapping. We're trapping errors at the point where input files come into the API and where there's an initial roadblock that occurs. And I'll explain some of the details on that. We're trapping errors related to the web soil survey. This is the NRCS Surgo soil model that we use. And we're collecting data from the Surgo soil model by hitting the WSS website that's located at the ITC here in Fort Collins. And so there's error trapping associated with using that resource. We're also processing the input files as they come in and checking for specific aspects of the input files, looking for misspelled tags and for incorrect options that have been entered, and then data processing errors. This tool still provides result XML files in the form of COMET-Farm results, and also still provides the JSON input file if you request it. But it also provides XML error files, and I'll provide some examples of what that looks like. I'm going to take another drink of water. Bear with me for a minute. So when a user submits a file to the COMET-Farm API, there may be an immediate failure that occurs. The tool is expecting an XML file. And if the tool does not receive an XML file, it will immediately respond with a result indicating that there's a problem with the file format. In other cases, we've had incidents where files were submitted and there was a spelling error, a syntax error in the closing tag, or XML tags were simply not closed. Those are also trapped immediately. And I don't know if you can see this on my screen, but this is an example from what you see from the GUI. This is also what would get reported back to the user, back to the listening server if they provided a URL. And then finally, if you've got an email address that's submitted, that's included in the tag, or within the email tag, within the XML file, but that email address is not registered as a user with the COMET-Farm system, then the file is simply not going to process, and the user will not be notified about that. Similarly, if the email address has a spelling error, if you're actually an authorized user, but you misspelled your email address, the file is not going to process. And we'd be happy to hear thoughts from people if you have another way to help correct those sorts of errors. But right now, what we're trying to protect ourselves against is essentially denial of service, one type of denial of service attacks. So moving on to some of the other error trapping. So web soil survey processing errors. There's 3 categories of issues that will lead to a processing error. The first is that the web soil survey is down. That does happen occasionally. We find that particularly in October of the calendar year, when the scientists at the ITC are updating the servo model, that the web soil service can slow down, and that the response time can be very lengthy. And it's simply because their database server is tied up with updates that are going on. And so in that case, if their database server is extremely tied up, then sometimes it'll provide no response within the listening window that we've set up, or it could simply be down. The second response is that no map units are available within the web soil survey database. And that does happen. There's a subset of areas within the US where that have not been mapped. And it's really unusual for people to be trying to execute model runs through COMET-Farm there, because these tend to be rock, ice, or desert landscapes where there's essentially no agriculture, no effective agriculture going on. And so, but occasionally that does happen. The third is that there's a map unit mismatch between the web soil survey and the COMET-Farm database. And this happens when the web soil survey has been updated and we don't have what we call the associated spin-up files within the COMET-Farm system that are available that we've executed to go with the map units that get reported back from the web soil survey. In these cases, in these cases, the error that you see here will be reported. So you'll first see this errors tag at the top of the file, then the model run with the name field, and then you'll see an index, and then the message associated with what the error is, and then finally the closing tags associated with the model run and with the errors tag. So the second set of input error trapping that we're executing is we're looking for an incorrect XML tag or a tag syntax error. And so that could mean you simply misspelled a tag name. And if a tag comes in that is not part of a list of accepted tags, we'll send a report back, or we'll report the error back to the user, and the file will not be executed. Other errors that we see are tag strings. Date strings are in the incorrect format. So one example might be an out of range, or an incorrect date, such as, for example, May 32nd, 2020. Harvest dates or cover crop kill dates must be after planting dates. These are all of these error trapping that we're seeing here are pulled from actual errors that have occurred from users sending files in, and also some of our own mistakes. And then finally, where a user may send in a tillage, fertilizer, irrigation, or other related type of event that's outside of the current year cycle within either the current model run period or a future scenario period. In addition to this, we check the input strings that come in against list contents. And so there's a number of tags within the tool where there's an accepted set of lists. And it could be as simple as yes or no, or it could be a list of crop rotation types that are valid for the county and region, or this would be for the historic crop period, or it may be from a list of actual crops that can be modeled, and the correct spelling for those crops that could be modeled within the system. And so we check all the input strings against list contents, and if there's a mistake, there we report those back. And then finally, we check where input numbers are expected. If there's a range that we're expecting and a number falls outside of that range, we check. And I'll give you some examples of what some of the error returns that come back look like. So in this case, we have a date error. So we enter a date here, 6/1/2016, the harvest date. But the harvest date in this case actually came before the crop planting date. And it's important that the harvest occur after the crops are planted. So this is one example of an error trapping that we do. The second example here would be where a user entered the wrong crop rotation name for a tag for the historic cropping period 1980 to 2000. A third example here was that a user entered just an invalid date, in this case May 35th of the year 2000, and so we're reporting that back to the user. And in every case where we can, we describe where the tag is and for the crop year to help the user zero in on where the error might be. Other examples might be where we're actually able to point to the specific line within the XML file where the error occurred. We're not able to do that in all cases, but in a number of the error trapping routines that we're running, we are able to do that. And the whole focus there is to help people speed up the process of being able to debug their input files. All right, and then finally, the last class of errors that we see within the system is a descent modeling error. And there's three different classes of errors that we encounter. There could be an exception that's built in from the Fortran compiler. That's probably the least common one. More common are IEEE errors, where a model run fails because not a number condition occurs. That's most likely a divide by zero or some other mathematical process that yields an IEEE error. And in some cases, model runs simply fail for unknown reasons. These are not very common, but they do happen. And they result from unexpected combinations of inputs, where we have combinations of weather, soils, and land management practices that create an error condition within the model. These JSON failures typically comprise less than about 1% of the errors that occur within the system. And when they do, you'll receive a notice that there is an error, a JSON error, and the text will be relatively nondescript because it's information that's coming actually from JSON, from within the Fortran code there. And what we ask you to do is to notify the CSU team if you receive an error like this for direct assistance for problems like this. We have not found a good way within to be able to identify exactly where, specifically what the problems are when these happen. Although we've dealt with these, we've been working with the JSON model for over 3 decades now, and we understand the model performance pretty well. So when a problem does occur, we're typically able to zero in on it relatively quickly. All right, I'm going to move on now to next step improvements, and I'd like to ask you all to start thinking about any questions that you may have based on what I've said so far. Let's see, so our next steps, we're going to be adding uncertainty estimates to the output coming from the API. They're currently available through the GUI, and we just haven't provided them through the API. We'll be adding other COMET-Farm modules to the API, including livestock, agri-forestry module, and forestry module. We're working to add a proxy history like the drag and drop so that the user could essentially, for maybe their current management or for their future management scenario, they could actually specify a crop rotation, and then we would automatically build that crop rotation for them rather than them having to go through and build those step by step, practice by practice, year by year in the input files. We're also automatically adding conservation practices to the future scenario. In the COMET-Farm graphical user interface, we've added a tool there called the Conservation Practice Advisor, and it's currently limited to 4 core practices. Being able to convert a current cropping system or current cropping period from whatever tillage they currently have loaded to a reduced tillage or a no-till system, or being able to convert to or add in cover crops under a couple of different scenarios related to different types of adjustments to fertilizer management. So we want to expand that list and make that available within the API. This is a bit of an aspirational goal, but we've been talking about this a lot within the Open Team environment. We'd like to build a common JavaScript library of acceptable input files that is something that we would make available through the GitLab repository, and then anybody could use. You can incorporate directly into your systems. There's a few other additional error trapping use cases we'd like to add. One of them is related to checking the spatial definitions for either vector field boundaries or a point-based field location. And this is related to validating the boundary, checking to make sure it's not a multi-polygon, that there's no holes within the boundary, overlapping boundaries, and these sorts of things. So we can check on that first before we try to execute a request to the web soil survey. Adding in a check for missed crop years. Perhaps somebody misses a year, and in this example, they have data for 2001, 2002, and 2004, but no data for 2003. Or multiple crop years, maybe they accidentally added data for 2001 twice. And then we are on a mission to continually improve our API documentation to help you, the users, as much as possible. And then I've put in space here for your suggestions. We'd like to hear from you about what your suggestions are about how we can improve the API documentation. And so I'll end now the presentation part. We can now pivot to Q&A and any comments or observations that you have. And I'll shift over here, and I'm looking at the questions. Okay, a question from Alvin. Are you willing to suggest target timeframes for implementing each next step improvement? That's something that we can get out to you all. So, and we'll make that available either within, tell you what, we'll make that available within the GitLab repository. Okay, next question. Were you able to reuse the error handling modules or error handling code from the GUI so that could be reused in the CLI? Yes, in fact, that was one of the key things that our software developers pointed out, is that we had done an awful lot of this and we were able to reuse some of it. Second part of that question is, or does the difference in the two technology stacks not allow for code to be used? No, we were able to reuse an awful lot of that. And actually it was error trapping within the tool that had been built in within the graphical user interface, that had been built in based on user requests, that really made a difference for us. All right, are there other questions that you want to post in the chat, or does anybody have a question they would like to just ask directly to the group and we can start a dialogue?
Mark, I have a question.
Yeah. Hey, Jose.
Yeah. Would it be possible for you to make available a JSON file or something that has the values of all the lookup tables? Seems like that's maybe a request for the future, but I wonder if for now, just having a JSON file that says these are all the possible fertilizers, these are all the possible tilling methods or whatever.
Yeah, that's a great question, and you're not the first person to ask for that. And that's something that we'd like to, we've talked about building a JavaScript library that could be available for users that would essentially be the basis of all of this. But what I'm hearing from you is JSON would be more helpful for you, and I wonder if you all could vote, whether it would be JavaScript or JSON or both, that if you could just post it into the chat what your preference would be, and we'll take that into account. All right, David has asked the question, any plans for a REST-style API? I'm going to put one of my colleagues on the spot, and I'm going to ask Mark or Shoga or Kevin, if he's on the call, if you have any thoughts about that, implementing a REST-style API.
As far as I know, and this is Mark Lair, we have no plans at this time to implement a REST-style API.
I'm curious about, from this group here, are there specific advantages that would be available for a REST-style API versus what we've implemented right now? And I don't want to put anybody in the spot, but I just want to understand more about the nature of the request.
From my perspective, a richer API would be useful, similar to this idea of having a way to fetch the lookup tables or any other thing that's required, even maybe a proxy to a soil database or some. I think if you have a REST API, it could be richer and add more functionality.
So this would be essentially where the data the model runs get processed, they get stored, and then the user can come back to them at a later time. Basically, you make a request for the results.
I think that what you have today for the results is good. Just having a way to a webhook or something for the results is good. but something more granular would be good too, where you could, get these other pieces of information from an API instead of having to grab it from a file.
I see. Okay. All right.
One more thing, Mark, it would be good
Okay.
if in the future we don't have to rely on an email address. If it was some type of token that could be changed. If not, people will use their email address and they move, and then it becomes a problem. I mean, I know you can use some service email address, but having some type of token or some other way to identify the request would be good.
So some type of a token that would be essentially auto-generated from our end. We provide the token that authorizes use of the API, and people could utilize that to send in a request.
Yes.
Got it. Okay. Okay, so I'm looking at in the chat, and the overwhelming request here is JSON. Right. I was trying to convince my wife to name our dog Jason when we first adopted her, and she didn't like that. I hope you all think that it was as funny as I did. Aaron, yeah, it was Jason. All right. What other questions do you all have or comments? Feature requests.
Limits on the number of requests we can make?
Yeah. So great question. The tool is currently set up, and I'm actually going to ask Mark Layer about that because he's been making some updates to the tool. And Mark, first of all, I guess the first question would be, how many model runs can you request within a single XML input file without essentially overtaxing the service?
That really depends on the shape of the individual runs, how many map units and how many crop rotations and things like that. We've done some tests, and based on the number of map unit cross crop rotations, like multiplying the number of map units by the number of rotations, I don't have the number off the top of my head, but we get the most success if the run is estimated to take about 15 to 20 minutes, like no more than that usually. And that's a per file thing. But the API right now, if you feed it a file with too many map units, too many locations, it will split it up into smaller files that will hopefully succeed better.
And so just to add a little bit more information to that, just examining the users within the model run requests coming through the GUI, graphical user interface. Each parcel or point typically has about between 4 and 5 individual map units, and each one of those map units, soil map units, has will define an individual model run request. When we execute our model runs within the system within COMET-Farm for our COMET Planner tool, we're typically sending in individual files with we're estimating 500 to 1,000 model runs within each file, and that we have good success with that sort of limitation right now. Mark, does that sound out of bounds?
Yeah, that sounds right.
And so there's essentially no limit on the number of files that you can send in within reason, but we really like to have you work with us and talk with us when you need to execute model runs, and so that we can carefully plan and make sure that the resources are available. Okay, so here's a request. please implement a native interface with Holos. Aaron, yeah, I would love to start a dialogue with you about that. And David, feature request, additional more than 2 crop scenarios per input XML. That's a really interesting idea so that we don't have to execute a baseline model run every time there's a scenario model run. And this is actually something that we've discussed internally. So I'll go ahead and add that to the queue as something that could be executed. And Mark Layer has just clarified the API allows up to 10 crop scenarios per XML location. So thank you for that, Mark. Okay, what other questions or comments are there? Okay, I'm not seeing anything else. So why don't we go ahead, we can wrap up the webinar here. I want to thank you all for your time and your attention. Please don't hesitate to reach out to us. My email is mark.easter@colostate.edu. And don't be afraid to reach out to me with other specific questions. So you want to start a thread or dialogue about this or any other related topic. Really appreciate your attention. We'll make this recording available to this group, and we're also going to update this to the GitLab repository as well. So you all take care, and looking forward to continue dialogue with all of you.